In the agenda and as announced was the title of the talk, ZIO-HTTP in comparison. Turns out after some preparation and seeing how much slides I have and how much stuff I want to talk about, the comparison falls a bit simply because, yeah, there is no time for all of that. Actually, I gave a version of the talk in a meetup, and it took me like 1.5 hours when I did like a deep comparison with other HTTP frameworks. So yeah, I thought I could boil it down a bit, but sadly not enough. Anyhow, I hope you would like to hear a bit about ZIO-HTTP, the latest version of ZIO-HTTP and what we are doing there. Quick question, who used any version of ZIO-HTTP before? Okay, who used any version of ZIO-HTTP in production? Okay, about the same people. And the latest version, like, so any kind of 3 version in production? Just the last check. Okay. Still a few. So there was, like, ZIO-HTTP was developed outside of the ZIO organization, then moved to the ZIO organization, and after that there were some bigger changes. So I'm now talking about like everything that is in this latest version, right? But before I start with that, maybe a little bit who am I? So my name is Nabil. I'm working for Rewe Digital in Germany, and I'm doing Scala for about 10 years. Why this talk? Yeah, so to take a look overall at ZIO-HTTP, how to write HTTP servers and maybe also clients, and what mechanisms we offer, how the syntax looks like, and yeah, it's basically a broad introduction. That was also what you can expect. So first of all, I would say what's actually the essence of HTTP servers, mainly in general, right? So you have some kind of routing, means you need to define an HTTP method, a path, maybe with variables, query parameters you want to pass your body. You need some kind of request response interception. You want to, in a generic way, modify your request, your response, do some side effects like logging, and maybe also some kind of validation. You want some kind of error handling, right? Every request can have an error, and you want to do this so that it doesn't affect other open requests, but just the requests that you're currently dealing with. You need some kind of concurrency for different reasons. You may like to access some resources. And of course, it's nice to have some kind of modularity and usability, so you can build handy building blocks that you can use in different places. And preferably things should be easy, right? So you don't want things to be complicated, because why? If it can be easy, it should be. So let's take a look first at a very simple routing example. You can see I have defined here some different routes, like different HTTP methods, a place where I get out a path variable that I put here in some variables that's outside of this route definition, but you have basically like little extractors where you could extract ins or longs or UUIDs or something like this directly from the path variable. And each route is then handled by a handler, which we will take a look a bit deeper later on, what a handler is. So one very important thing that you notice here is that query parameters are not part of the routes. And another thing that you might notice, this is not, as in most HTTP libraries in Scala, a pattern match or a partial function. Because what we are building here is just data, plain data, descriptions of the routes. And these descriptions offer us the option to build a tree, which is much more efficient for lookup than having partial functions, because with partial functions and maybe also combining the partial functions, right? So the lookup can be going like into ways very deep, and you have to try everything until you find the right one, and that's not very efficient. So John came up with some idea of, hey, let's encode this as data that is analyzable, and we will be able to build trees, and that's what we are doing. Therefore, even if you have like the requirement of building some HTTP server that is huge in the amount of endpoints, you can achieve very, very quick lookup times for your routes. And yeah, so a little comparison to HTTP4S here, right, where you have like the query parameters in the root, and also you have the pattern match, and you have this downsides that I just mentioned. So let's take a look at handlers. The easiest way to construct a handler is this handy handler function, which has some different flavors. So basically, you can either hand over the triple question mark. So, right, something's not implemented yet, great for the development. And then the two main other ways to construct it is you say, I provide a value or a zero effect with a value inside, and optional with the request as an input. This is like the basic of it. You can actually also hand over some more parameters, not only the request. How this works, we take a look later on. But this is like the simplest way you could have to create these handlers. So what is actually a handler? A handler is just an interface that can require a type parameter, an environment, just like ZIO itself, and then can create from an input either an error or an output. So I think that's as basic as it can get to handle basically anything or everything, right? So this is right now not specific to any kind of request or response, but when we want to, at the end, turn, like take this handler to be able to hand this over to some HTTP server that actually handles the requests. One requirement that we will have is that both the error channel and the output channel will be responses, because that's the only thing we can handle. And there are also more complex ways, more constructors, more sophisticated constructors to create handler. For this example, I made this with intention a little bit more complex, right? So I have here a root that just says a resource, and then ends with this trailing, with this, which is a wildcard for any path that is coming at the end of the root in this case. And then I say I built a handler from a function that also returns a handler, and it takes a path that is what is coming back from this trailing operator and a request. And I ignore here the request, take the path, and use it to call another handler that gets a resource as a file, flat maps this with another handler that can read from a file and create a response out of that. And in the case that there's any error, I map this to a response not found. So there are a lot of constructors of handlers that have different flavors that are very tailored, as you can see here, to different use cases. And if you want to take a look, open your IDE and use the autocomplete. There's like a lot of them. And if we would compare this maybe to player Akka HTTP, right? There are similar concepts in place. This is like an action or action builder, and in Akka you also have like this complete method or handle method that that look actually quite similar. The biggest difference here to ZIO-HTTP is what I said before. We have like a lot of constructors for the handler, and I think we are probably the ones with the most constructors, with the most specific constructors, with the biggest set of constructors, so that you don't need to think a lot about like this particular use case. How do I handle it? Do I have to write this again? Do I need to copy some code from some tutorial? But yeah, for a lot of stuff, it's already there. And I guess if you find some common use case that is missing, feel free to open a pull request. So that leads us to the question, what's actually with query parameters? If they are not like in the past, from where do we get them, right? So we can get them from the request. This is an example written with the RC3 from the version 3 of ZIO-HTTP. And yeah, you see I have here I get from the request the URL. On the URL, there is the query parameters. I get a per page. Flat map this with 2 int option because it's an int and not a string, right? And then I say get or else 10. And because I have another query parameter, I do something similar and then a pattern match. And when you see this, I hope you feel something like this, because I do. And this was totally not nice. And with the release that we had yesterday, it got a little bit better. The RC4 introduced at least some more convenient methods on the query parameter, where you can get with this get as or else some basic data types like ints, longs, UUIDs in a way that is a bit more convenient. But I think still it's like, yeah, it's kind of okay. You can deal with it. It's not that ugly anymore, but it's not really that nice. That's So I was actually thinking a bit about and trying out some stuff, and with a few lines of code, I came to something that works like this, where I can say like, I have some query that wants an int with per page, and that one is optional, and I have another one just page, and then what happens is I get this as some kind of context. How this works, we'll take a look on in a moment, and then I say like, hey, okay, I built now a handler that takes as an input not only a request, but also this per page and page. And then I think I have already coded that is quite good. It's not now anymore about the query parameter. Maybe you see some stuff that you don't like, but that's in maybe some unrelated to ZIO-HTTP, but I don't know, maybe you like the accessor pattern for your ZIO game service and don't like to call your service with ZIO or something like that. But that's up to you, right? And I think like, yeah, that doesn't look so bad, right? The syntax could maybe be a little bit nicer if we take a look back. So right now we have here like an arrow and some plus. Maybe you would like to have some question mark and end operator or something like this. But let's take a look first at request response interception, and then how this works in detail. So request response interception, often called middleware, that's also what it's called in ZIO-HTTP, is basically just something that takes a roots object and returns it. So then you ask yourself, yeah, what is actually a roots object? Turns out a roots object is just a collection of root objects, and a root object is basically 2 things, a root pattern and a handler. And when you take a look at how the root is defined, you can actually see this, right? This is like left of the arrow is the root pattern and right of the arrow is the handler. And this is actually powerful enough since the root pattern is just like some very basic values that you could also modify. So you could use like a middleware, for example, to put a prefix to a set of roots, so that you say like, you know, this is all the roots that should be available under /API or something like this. You could write a middleware like that. And the handler is so powerful and can be combined with other handlers in so many ways that it basically allows you to do anything and everything you want with inspecting responses and requests, and also modifying them. So let's take a look at some examples from that. So as I said before, we like constructors, right? So we have also nice constructors for the middleware. Here one that will add a log annotation to all the logs you will have inside handling your request, that adds here the user agent header, but you could hand over any other header. And there's also one that is just like log annotate, where you can hand over like a fixed annotation or an annotation that you can build out of the requests. That's then up to you. And after this very simple one, this one is probably the most complex that it gets. We have here this handler aspect. So handler aspect is a special subtype of middleware that can be applied to handlers. And this one in particular, you see it intercepts both request and response, and does this stateful. So what does it mean? I have here a function that, first of all, I hand over a handler that I create from a function that takes a request, then takes the clock from ZIO and gets the current time, and hands this over as a state to the next handler down here that now gets the time that I measured, the request and the response. And this way I can do some kind of access logging where I have log annotations for the methods, the status, the duration, and just write some empty log information just to have like an access log. And you can, as you can see now, this is like very powerful, and you can do with this whatever you want. Also, as you can see here, I create the handlers that return or that expect us to return ZIO effects. So you can not only use plain values, but also effects. And applying the middleware is quite simple. You have your roots object, and you just use this add operator. So like some kind of aspect, and you put your middleware there. Then the middleware for query parameters that I showed you before, we can also take a look now how to build that. I have like a very simple abstraction here that I just call query extractor, that has currently just two methods. It decodes that says like, okay, either you give me some success value or a response is an error, and an optional that just says, okay, if the either is a left, then you just return a none. And some implementation of this interface for integers, and then this actually query method that takes it as an input, and also here uses a middleware to extract the query parameter and return the query parameter to for us. As here, this output type from the handler aspect, because handler aspects can create a context, and this context is then what will be handed over to your handler that you apply the aspect to, and that's exactly what is happening here, right? So this operator has actually two meanings. So either I can have like this handler, or this one here is doing internally some builder pattern, and then will provide the context that comes out of the handler aspect via these two query operators that are concatenated to the handler, and then I have my per page and page query parameters, which I think is kind of nice. So you have this this basic building block of middleware that you take to also implement the query extraction, and probably something similar could be done with extracting bodies, which currently looks similar to what the query parameter looked like in the first iterations of my code, so that you still need to dig into the request and then get out some ZIO effect that represents the body. And I think at least maybe for some cases we can do that in a nicer way to extract the body. What is still a bit of a question mark for me is, so we also have like the option for streaming bodies, if this is also nicely integratable in such a API. I'm not so sure, but I am keen to take a look at this and will explore this. And this leads me to error handling. We have this roots object, right, which has an error channel that also has an environment, but this is for this stuff not so important. What is important is if I want to transform this roots object to an HTTP app, what is actually the object that can be served by our HTTP server, then the error has to be a response, right? So you cannot create an HTTP app that is servable except the error as a response. And that's basically the core principle of handling errors in ZIO-HTTP. You have to transform it to a response, right? And then you say like, okay, but how do I actually handle then the errors in my application? Well, that's very easy, right? You have like a handle exception method, and you have annotations. No, wait, that's catch an exception and rethrow some status exception. No. Okay. Yeah, maybe you have some custom exception with an annotation that says if this annotation is thrown, not found. No, just kidding. Of course, all of this is Spring stuff that we don't do. We use just ZIO. ZIO has perfect error handling. You have the effect, you have error channel you can map, and that's actually all the stuff you need for nice error handling besides this requirement. I forgot to change the heading of the slide. It should actually say something like leftovers. So we had some other stuff in the beginning, right, that I said were important, like concurrency and resources. What's the answer for that? Again, ZIO. We don't need anything special built into ZIO-HTTP. We have already ZIO, and that's enough for that. And I would say modularity, reusability, and simplicity is by design. And this is basically by having composable small building blocks like the handlers that give you the opportunity to build some nice stuff that is reusable, but also the sorry, I forgot what I wanted to say. Skip. And a lot of specialized constructors that are tailored to your use cases. Now, what's interesting is we also have the second API to define endpoints. You might have seen this in one of the other talks. Daniel talked about this yesterday, and Jorge today. And this way, I think, is very nice and concise to define endpoints, which basically is, you say, I want to have an endpoint. Here is my path, right? This is the same like what we used before. But now you can go and say like, hey, I need a query, and the query parameter that I'm looking for is like per page. It's an int query, and I have this optional operator, which looks similar to what I try to build, which is not yet in ZIO-HTTP, but I hope will come soon for the standard API. And I have another query, and I have some output parameter, and I define this here all right, but this is just data. This does nothing. But it gives us the opportunity to have something that is analyzable. And based on that, we can then implement different things. So the first choice is to call this implement method, which will return a root. And you see, you can also use here the handler constructor or any kind of other constructor for handlers that then you can use to delegate the call to your service. And that's a duplicated slide, my bad. And then you have the option to do the same, but for the client side. So if I say I have this little invocation object where I say, like, I want to call basically this game's endpoint, and I hand over the 2 query parameters that are required, then if I also give something that says, like, where should the call go, I can take a ZIO-HTTP client and an endpoint executor to execute this games object, and will get back an effect that will return for me this chunk of game what my API offers. But not only that, just released yesterday with the RC4, we also support OpenAPI. So this means if you describe your endpoint in this very general API, you can actually also for all of the parts, for the output, for the input, for the query parameters whatsoever, there are operators that you can use to add documentation, and this will then all be generated to an OpenAPI spec that you could hand over to, I don't know, another team, a customer, whoever needs to call your service. And I think that's nice, you know, having analyzable data structures, I think is the key here. And there will be for sure much more use cases that will come out of this, generating other clients, generating, I don't know, Postman collections or whatever you like, because this data is very high level, right? And you can do basically whatever you want with it. Thanks for listening. Thanks for ZIO-Verge, for Golem, for sponsoring this event. Then I hope you have a nice rest of the evening in the conference.